What we have growing here are wheats that have been derived from synthetic hexaploid wheats, which were produced at the International Wheat and Maize Improvement Centre in Mexico City. What they've done there is gone back to the original source of wheat. Bread wheat evolved in the Middle East thousands of years ago from a natural cross that occurred between a durum wheat, the sort we make pasta from, and a wild grass called Aegilops tauschii to give us a combined wheat, which was, over the years, has been found to be suitable for bread making. Now, that happened on a few occasions there, and out of that we've got all the bread wheats that we grow in the world. But scientists at CIMMYT found that they could go back to the original sources of these in the Middle East and reconstruct a bread wheat from the wild grass Aegilops tauschii that occurred there and with modern durum varieties. And this has been used as a great way to bring disease resistances into the modern wheats. And what we've found is that a number of these, which we've screened in the past, have resistance to both nematode species that bother us, both root-lesion nematodes, the Pratylenchus thornii and Pratylenchus neglectus. So these are really a prized source of resistance, and we've in the past crossed these into some of our local bread wheats, and here we're screening them, trying to get wheats that will have resistance to both. These won't make commercial wheats. We're no longer in commercial wheat breeding, but we will be able to deliver these to the wheat breeding programs, and they'll be able to make their own crosses, knowing that they've got good resistance in an adapted background. And hopefully these can help turn around these problems with nematodes in the northern region and elsewhere in Australia. In further work involving these synthetic hexaploids, we're working with the Australian Wheat and Barley Molecular Marker Program that's centred in Adelaide and led by Diane Mather and Ken Chalmers. And in that, we're hoping to look for molecular markers to these disease resistance. And some of the plants you see here are so that we can count the nematodes and, in association with them, develop molecular markers that can be used for screening in the future.